Welcome back, chemistry fans. Today, what we're going to do is the Unit 5 exam, and we're going to do some of the free response questions dealing with all of the naming of the compounds. So let's jump into these. Okay, so what we have in this scenario here is an acid, and we know it's an acid because it says it is, but it's got this suffix on it, and it's telling us that it is polyatomic. Whenever it has that OUS or an ic ending, it's polyatomic because there is no prefix. If it were a prefix, it would just be binary. So we're trying to write the formula for this one. So you would have to know your polyatomic ions, that this is sulfate, the SO3, that is the sulfite, and the ite ending is the one that goes with the OUS. So what we would have here now is an H with a positive charge and the SO3 with a -2. That means that they're not equally balanced. We've got to put the charges in the air. We got to crisscross them down like we just don't care. And so we end up with H2SO3, or you could just write H2SO3. Okay. Next, number 2. I see that this one is a transition metal. Now, how do I know it's a transition metal? Because there is a Roman numeral. So I look on my periodic table, I see vanadium is right here in the center at number 23, verifying what I just already documented with the transition, with the Roman numeral that's in there. So I'm going to have vanadium, and its charge is based on this Roman numeral. So that's a 6, Vi. Silicon is the element silicide. And so what we're going to do is go over here and find out what its charge is. Silicon is in the same row as carbon. We look up here, and it is a non-metal, and so it's going to have a charge of -4. And so I've got these two charges up in the air like they just don't care. And so I crisscross applesauce, and I end up with V4Si6. But that needs to be reduced down. So I'm going to have V2Si3. Okay. Acetate in the third one is a polyatomic ion. You would not find that on the periodic table, so you would need to go and look it up. Acetate has the polyatomic formula C2H3O2 with a -1 on the whole detail. Now, gallium, I'm going to go and look on my periodic table and find out what its charge is. It's in this 13th column. It is going to have a charge because it is a metal, so it's going to have a charge of +3. All right. So +3 for gallium, and acetate with the -1. I'll just put it right next to it. Those two charges are not equal and opposite. So I'm going to put the charges in there. I'm going to crisscross them down like I just don't care. And so I end up with GaC2H3O2. It must have parentheses. The one that is optional after that crisscross. Okay, moving on. So now I'm going to have to write names. Now, this one goes back to the original statement. I do know that this is an acid because it begins with the letter H. I know that it is binary because there's only 2 elements. I go and I look up what AS is, and it's arsenic. But because it is an acid, it actually gets to keep its IC ending. Now, the prefix, because it's binary, it must add a hydro. So my name is hydroarsenic acid. Now, it's just pronounced differently, but it would be written the same way. And technically, it'd be a lowercase a. So hydroarsenic is one word. All right. Number 5. Now, this one has no prefix hydro in front. So I know also that it is a polyatomic acid. PO4 is phosphate, and PO3 would be phosphite. So the higher number of acids takes the ic, and that means we're going to be using phosphate. So to balance the fact that it has 3 as a negative charge, I'm going to have to put in 3 hydrogen. So my formula is H3PO4. All right, moving on to number 6. So on number 6, what I've got is now the inclusion of a different form of acid. Again, it is a polyatomic acid, but we have to know what NO3 is. NO3 is nitrate, ATE. NO2 is going to be nitrite. And so matching up the NO3, I'm learning that I have to put the ic ending. So this is just going to be nitric acid, not nitrous, and there will be no prefix out front because it's not binary. So it's just nitric acid. All right, moving downward. I've got then prefixes. Because it's prefixes, I know that both of these elements are nonmetals. The prefixes become the number of atoms. There is no switching of them. So it's just N4Cl7. The next one, calcium and nitrogen. I need to go and figure out what their charges are on the periodic table so that I can match it up and crisscross applesauce with it. Calcium and nitrogen. Calcium is over on the left side. It's in the it's in the +2 charge. Nitrogen is over here on the right-hand side, and it has the -4 charge, -3 charge. Gosh, +2, -3. So I'm going to put those charges in, +2, -3. Those charges are in the air like they just don't care. We're going to crisscross them down and throw them to the ground, and you end up with Ca3N2. There is no reduction needed on those. Next, I have another acid. How do I know that? Because it has an H in front. That tells you it's an acid. So chlorate, it's a weird one. There are 4 different chloride oxygen polyatomic ions. There's perchlorate, there's chlorate, and then there is chlorite. These are where the ites start, and this is hypochlorite down below. So we just got to match it up. And so we're going to be using this Cl2 as ITE, meaning it has a lower number of oxygens. So the name of this one is just going to be chlorous acid. 2 words, chlorous acid. Okay, now the next one, it does show a prefix, and that means that we are going to have an acid that is binary. My charge on hydrogen is +1. I'm going to go and look up my charge for arsenic off of the periodic table. Arsenic has a charge of -3. So now I'm going to take that. I'm going to put those charges in the air. I'm going to crisscross them down like I just don't care. I'm going to end up with H3As. All right. Now we are on to question number 11. We are 2/3 done with this, almost to the end of the free response questions. So let's jump into this first one. We are done with what appears to be acids. So I've got a polyatomic ion. I know that because of the suffix. So I'm going to go and look it up on my pink sheet. Carbonate has a charge of -2. Strontium, I need to go and look up off the periodic table and see what its charge is. Its charge for strontium is over here right underneath calcium. So it has a charge of +2. So it looks like what I've got now is a +2 and a -2. +2, -2, those are going to cancel out. So my answer can have the parentheses if you want. It doesn't have to. It could just be SrCO3. All right, name of the next one. Aluminum and bromine. These are 2 normal elements. I've got to go and look up what their charges are on the periodic table. Aluminum is in the same column as gallium, so it has a +3. And I forget what the other element was just as quick as I've said it. So bromine, it's going to be in the 17th column. It's way over here on the right side, and it's going to have a charge of -1. Okay, So I've got -1 for the BR. I've got +3 for the AL. Those two charges are in there like they just don't care. They're going to crisscross down, and I'm going to end up with AlBr3. If you want to put the 1 in, that's fine. It's not necessary. Oh, what's the name of it? That's already been figured out. All I need is the name. So we put down the name, aluminum bromide, IDE ending is what we got to do. All right, well, that one was much simpler. I made it much more difficult than what it should have been. And the next one also needs a name. So because this are both nonmetals, we are going to use prefixes. So I got hexaselenium trifluoride, IDE. So the prefixes stay with the elements. They do not switch because they've already been balanced based on the fact that they're both nonmetals. And my last one is a Roman numeral because it's rhenium. Rhenium is an element in the middle of the periodic table. It is Re, but we don't know what its charge is. So we have to rely on the Wonder Woman move to inform us what Roman numeral we're going to use here. So I got rhenium oxide as the element or as the compound, but I got to figure out what the Roman numeral is. So I'm going to cross backwards, and it should be a +7. And let's go verify now that oxygen is a -2. So oxygen over here, it does have a charge of -2. Therefore, that 7 is the correct charge for rhenium. So I'm going to put in here a Roman numeral of 7. If you want to put them in parentheses, that is perfectly fine. Okay. I believe, if I'm not mistaken, that is going to take care of all of the questions dealing with the naming of compounds. We will pick back up with the multiple choice questions in just a second. So thank you very much for your time. Hopefully this will help you fix these. Go and do practice problems now so that you can earn your points back. Thanks a lot. Bye-bye.